So let's start with this second part, formulas and functions. So last time what we were looking at the basics of Excel, where we talked about the go-to boxes and other things and how we navigate and other things. Now we'll go to something that is basically why we use Excel. So we use Excel for our formulas and functions. Now, just give me. So when we talk about formulas and functions, there are more than 600 inbuilt formulas. So when we talk about formulas, there are two ways of looking at it. One which is inbuilt and which is UDF, user defined. So when we talk about inbuilt, there are more than 600 inbuilt functions that you have in Excel. So can we know all of them? No, it's practically impossible. So what we are going to do, we are trying to understand how we read a formula inside an Excel. And then we look at a normal data analysis set of functions. So when we talk about the functions, the basic structure of a function is f, and then you have these brackets, which we call them as parentheses. In Excel, we call these brackets as parentheses. Inside the parentheses, whatever is written is known as argument. So we call them as arguments. And arguments are separated by comma. So every function has the same basic form. You have function, argument 1, 2, 3. The function part is always in the uppercase letter and the arguments are separated by commas. Many functions don't have arguments and they are like this. You have rand, then you have today, we'll be seeing them too. Then you have now, which is open and close parenthesis. There's nothing inside it. So whenever you see a function which does not have any arguments, they are dynamic in nature, which means whenever we are working across these functions, these values will automatically change. As the Excel refreshes its calculation, the value of these functions will automatically change. The way arguments appear is known as syntax. So when we say syntax, say for example, what is the syntax of VLOOKUP? So we are trying to understand how that VLOOKUP is written. So arguments in square brackets are optional. You will find a lot of arguments which are like this. Arg1, and they would be closed like this. So they are optional. Optional means, remember, what does this word optional mean? Whenever we say optional, it means it is not going to give error. If we do not write this argument, it is not going to give us error. But does it guarantee the right answer? We cannot say that. Some functions, yes, some places, no. So we'll look into that. Now, before we go into formulas and more into it, let's understand the orders and precedence. So let's start with the operators: addition, subtraction, multiplication, division, to the power, and parenthesis. This is shift plus 6. For example, we need to write 2 to the power 2. So this will come from shift and 6. Then we have operators. So operators could be equal to, less than, greater than, less than, greater than, equal to, less than, equal to. You would be knowing most of it. This is something new, not equal to. When we try to find if cell A1 is not equal to, so we'll put like this, A2. Next thing that you need to understand is the order of precedence. Same as BODMAS. We follow the same thing. We call it as PEMDA. If you remember BODMAS in mathematics, same way we have PEMDA. So first thing that gets worked upon is parentheses, which are this brackets. Then reference operator, A1 colon A20. This is your reference operator. Then exponential is, so PEMDA stands for parenthesis, exponential, multiplication, division, addition. So then the exponential will get solved. Then comes multiplication and division. They have the same hierarchy. So whatever comes first from the left hand side will be solved first. So if you have something like 2 into 3 divided by 6. So when you look at from this side, the multiplication is coming first. So this will happen first and then this will happen. Same with addition and subtraction. So if I write 2 plus 3 minus 6, this will get evolved first and then this will happen. Then you have ampersand. This is and sign, which is basically a concatenator. We call this as concatenator. We'll see this and thing into our VLOOKUP as well as we'll look into this ampersand into our text functions. Then the comparative symbols. Now, why is this PEMDA important? Because a bracket in Excel here and there makes a lot of difference. So if we are writing something like, let's just go into Excel itself. Now, when I'm going inside, let's talk about a CAGR formula. Now, when you're writing a CAGR formula, it is say 100 becomes 200 in 10 years, let's say. So CAGR formula is 200 by 100 whole raised to power 1 upon 10 minus 1 minus 1. Now in Excel, if you do not put the brackets properly, this entire formula is going for toss, which I'll show you when we start working into the formulas and functions. I'll show you how brackets can make a lot of difference. So if you write in mathematically, let's say, let's write an argument 2 plus 3 into 6 plus 10. So this will give you, if you look at mathematics, 18, 28, and this will give us 30. Now, if I put brackets inside, let's say like this. If I put two brackets like this, then what will happen? These brackets will get solved first. So this will be 5 into 16. So 95 kind of a thing will come in. So the answer will change based on these brackets. This is why this is important, because this is how we will be solving the problem inside Excel. Now, what if we have more than one bracket? After an equal to sign, we have bracket, then again bracket inside. So how this entire thing is going to solve this? The inner bracket is solved first, and then the outer bracket. It is more like saying that when you put a stone inside the water, the inner ripple, then the outer ripple, then the outer ripple. So it goes like this, this, and this. So this is how Excel will actually start working on the operator on the parenthesis. So parenthesis will play a very important role. As in when we go forward, we look into the role of those parentheses. Remember this PEMDA. It is more like BODMAS, but in Excel we call this as PEMDA.